In this video, we will be explaining how bulletproof vests work and the physics behind them. If you have ever seen a crime show, you have most likely watched the scene where the characters are wearing bulletproof vests.
I only want Doyle. Where's Doyle?
Right here, love. Right here.
In this video where Emily Prentice gets shot, she was wearing a bulletproof vest.
There it is.
You see her fall to the ground from the impact of the bullets, but she's still alive. The bullets never actually penetrated her abdomen. But what actually happens when the bullet-resistant vest is shot?
Before we go into the physics of the vest, we need to clarify some things. Soft body armor can only be shot a certain amount of times before it is compromised. The word bulletproof gives the connotation that when you are wearing one of these vests, you can't be shot, which isn't what happens. The bulletproof vests are not really bulletproof. They're more like bullet resistant. When the vest gets shot, the bullet isn't able to penetrate the material, thus making it bullet resistant.
Many types of bullet-resistant vests. One of these is made out of Kevlar material. Kevlar is made from polyacrylamide plastic fibers that are tightly woven together. It's a very strong material. To make a bullet-resistant vest out of Kevlar, the maker takes Kevlar material and sews it together with thread intertwining the layers of Kevlar material together. This makes the vest able to resist penetration from a bullet.
Think about it like a soccer net. The soccer ball represents the bullet, and the goal represents the bullet-resistant vest. When someone like Carly Lloyd shoots, the ball has energy in the form of inertia. This inertia hits the soccer netting made out of tethers intertwined together and then attached to the frame. When the ball hits the net, the tethers are pushed back at the point where the ball comes into contact with the net. But each tether is intertwined. The rest of the net extends and disperses the inertia from the point of impact throughout the entire netting. The Kevlar material of the bullet-resistant vest acts exactly like the soccer netting. When the bullet pushes specifically on one horizontal strand of Kevlar material, all of the vertical tethers are pulled by the horizontal strand because all of the strands of the vest are interlaced. One way the Kevlar material is not like a soccer netting, though, is the fact that the soccer netting stretches when the ball comes into contact with it. The Kevlar material doesn't stretch well. In fact, it barely stretches at all when the inertia hits it.
Disperses the inertia from the bullet throughout the entire vest. A vest made out of Kevlar is a great option for soft body armor because it's flexible. So now you're probably thinking to yourself, if a Kevlar vest is bullet resistant because of the way that the fibers are bound together, can't you make the materials into bullet resistant fabrics? And the answer to this is yes and no. The beginning of body armor came from the leather that the Romans wore. As weapons progressed, the body armor also needed to become more durable, and that meant it became heavier. By the time the first guns were used, most body armor weighed about 25 kilograms. But the armor didn't need to be heavier. The wearers just needed to think of a different material than metal to use.
The bullet works by concentrating a mass amount of energy into a small amount of space. If you increase the area that the bullet is coming into contact with, it becomes harder for the bullet to penetrate. Some Koreans realized that if they could make the surface area bigger against the bullet, they had a chance of stopping it. The first vest used against guns was actually made out of layers of cotton. The problem with this was that the cotton wasn't strong enough to endure the newer and stronger weapons that were being created. Why didn't they just use metal, like steel, you may ask? Because they had already found out that using metal to stop bullets, though it may work, it was very tiring and heavy to carry around. Modern bullet-resistant vests are made out of Kevlar because pieces of Kevlar is 5 times stronger than a piece of steel of the same weight. Type of bullet-resistant vests are made out of Kevlar and ceramic plates. The problem with these vests are that in fact they are still heavy to carry around. The Kevlar vest is strong, but not strong enough to use in battle. Although the ceramic plates may add strength to the vest, it can only be shot once. The ceramic plate works by being sewed into the middle of a Kevlar vest so that you have Kevlar material, a ceramic plate, and then more Kevlar material. The Kevlar works to slow the bullet down enough so that the ceramic plate can then make the mass amount of energy from a high-strength gun and disperse it throughout the entire plate before the bullet can penetrate the last layer of Kevlar. The ceramic plate has been hit with the bullet. It turns the inertia from the bullet into heat energy. Many people have said that once they were shot while wearing a ceramic plated vest, the amount of heat that radiates from the ceramic plate is so hot that they were required to take off their vest in order to not be burned. The mobility offered from a bullet-resistant vest made of Kevlar is more desirable than the mobility offered from a ceramic-plated vest. But on the flip side, the protection gained from a ceramic-plated vest is greater than one of the Kevlar vest. Although each vest has its own downsides, both are better options compared to the vulnerability of wearing no bullet-resistant material.
We hope that now you understand the physics behind bulletproof vests. Thanks for watching.